For the first time in human history, scientists have detected unusual light signals emanating from a distance of 7 billion kilometers from Earth. This remarkable discovery has ignited an intense wave of curiosity and speculation about the possibility of extraterrestrial life. The source of these signals? Proxima Centauri b, the closest known exoplanet to our solar system, located just over 4 light-years away. Observations from the James Webb Space Telescope, JWST, revealed bright, intermittent lights on the surface of this distant world. Signals that appeared to be structured and deliberate, unlike anything previously observed in the cosmos. For centuries, humanity has looked toward the stars, hoping to discover signs that we are not alone in the universe. Each hint of activity beyond our solar system, each anomaly in distant star systems, has been met with excitement, anticipation, and sometimes, disbelief. Now, the James Webb Space Telescope may have provided the most compelling evidence yet of something extraordinary. While surveying the cosmos, the telescope captured what astronomers have called urban lights on Proxima Centauri b. As the name suggests, these lights resemble artificial illumination, akin to the glow of a city on a planet's night side. The discovery raises profound questions. Could this exoplanet host intelligent life? Could there be civilizations developing technologies and societies far beyond our comprehension? The implications of such a discovery are staggering. For decades, astronomers have studied Proxima Centauri b with a mix of fascination and caution. Its proximity to Earth makes it a prime candidate for detailed investigation. Yet until recently, observations were limited to indirect measurements of its orbit, size, and mass. JWST's advanced infrared capabilities now allow scientists to examine its thermal properties and detect faint emissions that could reveal not only the composition of its surface and atmosphere but also signs of artificial activity. David Kipping, an astronomer at Columbia University, describes Proxima Centauri b as a celestial body exhibiting unusual thermal behavior that sets it apart from typical rocky exoplanets. Whereas most rocky worlds absorb sunlight and gradually release it as infrared radiation, Proxima b shows distinct temperature variations and infrared emissions that differ from those of its host star. These anomalies may be indicative of energy manipulation on the planet's surface, possibly even the presence of structures that capture and redirect light or heat. This is where the JWST becomes invaluable. Its ability to observe in extremely narrow infrared bands allows it to separate faint signals from the overwhelming light of Proxima Centauri, making it possible to detect even the dimmest forms of illumination. This sensitivity is critical for identifying potential artificial lights on the planet's night side, where natural sunlight is absent. By analyzing these emissions, scientists can begin to map out the thermal and atmospheric patterns on Proxima b, providing critical insight into its habitability and potential for hosting life. Interestingly, Proxima b demonstrates a complex interaction between its star and its planetary environment. The planet is likely tidally locked, meaning one side permanently faces its star while the other remains in darkness. The day side could experience intense heating and possibly support mechanisms to harness energy, while the night side remains extremely cold. These conditions create sharp thermal gradients, which JWST can detect and analyze to provide a detailed picture of the planet's atmospheric dynamics and energy distribution. Understanding these patterns is essential not only for evaluating the presence of life but also for modeling how the planet's climate and surface conditions might evolve over time. JWST's observational capabilities extend beyond thermal analysis. Its orbit around Earth allows continuous monitoring of Proxima b's day-night cycle over 11.2 Earth days, capturing the complete rotation and enabling detailed assessment of both the illuminated and dark regions. Scientists can use this data to study variations in temperature, light reflection, and atmospheric composition, looking for patterns that could indicate organized activity or artificial structures. The next critical step involves probing the planet's atmospheric chemistry. Detecting key gases such as oxygen, water vapor, and methane is essential because their presence could suggest conditions conducive to life. These molecules are considered biosignatures, substances that are typically associated with biological activity. Oxygen, in particular, is a strong indicator because it is highly reactive and would require constant replenishment, potentially pointing to photosynthetic life forms or industrial processes. Methane and water vapor can also signal active chemical cycles that are difficult to explain through geological processes alone. However, capturing and analyzing these signals is extremely challenging. It requires isolating the faint light rays passing through Proxima B's atmosphere and separating them from the overwhelming radiation of the host star. JWST excels at detecting variations in water vapor, carbon dioxide, and methane concentrations, but oxygen detection remains a limitation. Despite this, scientists can look for ozone, which forms from oxygen and provides an indirect marker of biological activity. The combination of these gases, alongside thermal and light emissions, offers a multi-dimensional picture of the planet's habitability. It is important to remember that JWST cannot observe every potentially habitable exoplanet. Its focus is limited to the closest and most promising candidates. To expand the search, astronomers are preparing ground-based observatories such as the Extremely Large Telescope, ELT, set to become operational in 2028. The ELT's massive aperture and advanced instrumentation will allow deeper investigations into exoplanet atmospheres and the detection of faint light signals. By combining JWST and ELT observations, scientists hope to distinguish between natural and artificial sources of light, as well as between gases produced by geological activity and those indicative of life. The discovery of unusual lights on Proxima Centauri b also raises theoretical questions about the nature of extraterrestrial civilizations. If these lights are artificial, they could represent urban development, energy generation, or other forms of advanced technology. They might be a sign of an intelligent species capable of manipulating its environment on a planetary scale. Alternatively, the lights could result from natural phenomena that are currently unknown to science, such as highly reflective mineral deposits, unique atmospheric effects, or other processes that mimic artificial illumination. Regardless of the explanation, the potential discovery represents a major step forward in our understanding of the universe. For decades, scientists have scoured the skies for evidence of life, using every tool available, from radio telescopes scanning for signals to infrared observatories studying planetary atmospheres. While no definitive proof has been found, each anomaly, each unusual observation brings us closer to answering the age-old question: are we alone? Proxima b, with its intriguing lights and atmospheric peculiarities, may provide the first tangible evidence of life beyond our solar system. The James Webb Space Telescope has opened a new frontier in exoplanet research. Its unprecedented sensitivity, advanced infrared imaging, and precise observational capabilities allow humanity to explore worlds that were previously beyond reach. Proxima Centauri b is now a prime focus of study, offering an opportunity to investigate not only the possibility of life but also the nature of planetary development, atmospheric dynamics, and the potential for intelligent civilizations. As technology continues to advance, future space telescopes and ground-based instruments will build on JWST's discoveries. They will reduce the glare of host stars, allowing even subtler signs of life to be detected. Scientists will be able to analyze exoplanet surfaces and atmospheres in greater detail, identifying potential biosignatures and artificial phenomena with unprecedented precision. Each discovery brings us closer to understanding the complex and wondrous universe we inhabit. Despite decades of research, humanity has yet to find a planet definitively capable of supporting life. The observation of these urban lights on Proxima Centauri b challenges our assumptions, ignites our curiosity, and reminds us that the universe is far stranger and more fascinating than we ever imagined. We are only beginning to glimpse the possibility of life beyond Earth, and the coming years promise discoveries that could fundamentally reshape our understanding of existence itself. Proxima Centauri b's mysterious lights are more than just a scientific curiosity. They are a reminder that the universe still holds secrets beyond our comprehension. They invite us to ask bold questions, to explore further, and to remain vigilant in the search for life among the stars. Humanity's journey into the cosmos has only just begun, and every new observation brings us closer to answering the ultimate question: are we alone, Or has life found a way to thrive far beyond our solar system? The James Webb Space Telescope represents a monumental leap forward in this quest. Through its observations, scientists are not only studying distant worlds, they are uncovering the potential for intelligence and complexity that rivals our own. Each light, each thermal signature, each atmospheric anomaly observed on Proxima b tells a story waiting to be decoded. The universe is speaking, and for the first time, humanity may be ready to listen.